Quick question.
Go ahead.
Is it analysis toolpack or analysis toolpack dash VBA?
The analysis toolpack. I don't need that. We don't need the VBA.
Okay, thank you.
All right. Let's start. All right. So today we are going to talk about. Let me mute all of you, and then you can unmute if you need to talk. Okay. So last class we talked about simple linear regression. I hope you remember at least some of it, the concepts, because we are going to use the similar concept. Okay, I got a question in chat. What room are we meeting in? Yes, I'm going to send you an announcement, okay, before class. So you'll receive an announcement from me on Monday. Okay? All right. So last class we talked about simple linear regression. Today we're going to talk about multiple linear regression. So it's just going to be an extension of the concepts that we learned for simple linear regression. However, we'll see that we have to use different tools to do regression than doing scatter plots. And that's why that's the reason we need to get the analysis toolpack in our laptop or in our computer. But again, when we do that, I'm going to show you again how to do that. But in case you have already added, so you're good. All right. So next class is going to be our first classwork, in-class classwork. If you have already sent me an email saying I want to be working with this person, you are good. I'm going to put you in a group with that person. Or if you have told me that you want to work alone, that's also fine. But you haven't, so I'm gonna pair you up with whoever you are sitting with, basically. Okay. So it's gonna be either two or three, depending on the class size. But yeah, just be prepared that I'm gonna partner you up with the person that you're sitting with for the next classwork. And then after the classwork, I'm gonna send out a sign up sheet for groups, right? So you can then finalize your groups if you haven't already emailed me about that. All right. So the way the classroom is gonna work is basically I'm gonna give you a question and most likely I'm gonna give you the question beforehand, right? And the questions will have parts of it, right? And then in class, I'm gonna show you or at least discuss with you how to solve the problem, right? And then maybe you'll do it on your own. And whenever you're stuck and you want me to check if you did it correctly, I'm gonna come by and help you. Yeah, I mean, all the classworks, I think you should get full points. You shouldn't lose any points on classworks because you can basically call me and I'll tell you if anything's wrong or if anywhere you're stuck. All right. So today we will do, as I said, we will do multiple linear regression, but within that, we are going to look at two different cases. So the first thing we're going to look at is simple extension of the simple linear regression in the case that we have more than one independent variables. But still, all the independent variables are numbers. Okay? So it's going to be like 1, 2, 3, or some numbers, just like we saw before. And then I'm gonna also talk about what happens when the independent variables are not numbers but a category. And what do I mean by that? So for example, your data could be, for example, the shopping behavior of a person could depend on the person is, what gender the person is, right? So in that case, your data will have male, female, right? It won't have a number. So how to tackle those kind of data when your data says it's a belongs to a category, in this case, the category could be male or female, and it's basically words in your data, not any number, right? So how to deal with that, that kind of regression or independent variable, we're also going to talk about that. All right. So just to recap, what we did last class is we did talk about regression, where regression analysis shows how a dependent variable, which we will also symbolize as y, right, depends or can be explained by an independent variable, which we also call x. And the simple linear regression model is basically says that y, your dependent variable, is equals to a constant plus something multiplied by x, right? So that means that it's related to x through these parameters, beta naught and beta 1. And the error term basically captures the variability that cannot be explained by x, right? So the variability of y that cannot be explained just through x. So what we did is we looked at sample data, and then through the sample data, we basically estimated your beta naught to be b naught and beta 1 to be b1, such that this error is minimized. Okay? So what we got out of regression is the equation, right, or a model. And the equation that relates y and x through b naught and b1. So we got these numbers, b naught and b1, and because we have now the b naught and b1, this is the equation of y and x, which can give you prediction of y for a given x, right? That was the whole idea. So, and then we also looked at R square. We talked about that R square being a goodness of fit, meaning that R square basically tells you how good your model is, or how much variation of y can be explained by this regression equation. So we're going to talk about these terms again and again. Right? It will become easier on your ears. All right. So just going to be an extrapolation. What is a multiple linear regression? In this case, we have multiple x's. So all the time, you will always have one y or one dependent variable. That's something that you are trying to predict or something you are interested in. But you will have more than one, you may have more than one independent variables. Right? So in this case, I have q number of independent variables, like x1, x2, all of these are my independent variables. So let me give you an example. Remember our examples of simple linear regression when we talked about dependent independent variables. So we looked at predict questions like how to predict ice cream sales based on weather temperature. So now my question is to understand the effect of weather temperature and humidity on ice cream sales. So to answer this question in your regression, what's going to be your dependent variable and what's going to be your independent variables? So just to recap, your dependent variable is the variable that you are trying to predict, that you're trying to estimate, that variable that depends on other things. Okay? And your independent variables are the variables that is helping you to predict your dependent variable. It doesn't depend, but the dependent variable is dependent on the independent variables. Right? So what's going to be the dependent variable and what's going to be the independent variables in this example?
Ice cream sales is dependent, weather and humidity are independent.
Right, very good, right? So we agree. So basically we're asking quantify or estimate or predict the effect of weather temperature and humidity on ice cream sales. So ice cream sales depends on weather temperature and humidity. Weather temperature doesn't depend on ice cream sales. So in this case, my ice cream sales is going to be dependent variable, and weather temperature and humidity going to be my independent variables. So as you can see, in this example, I have one dependent variable, but two independent variables, right? So it's not a simple regression anymore, because in simple linear regression, you will have one dependent, one independent, right? So this is going to be a multiple linear regression. All right, how about the second one? you want to understand the effect of social distancing and vaccination on COVID-19 infections. So what's going to be your dependent and what's going to be your independent variables? Anyone else?
Depending gonna be the humidity. What we on? Social distancing. We on the second one?
Can you say that again? Sorry, I missed.
We on the effective social distance. That's what you said.
So you're trying to understand the effect of social distancing and vaccination on COVID-19 infection.
COVID-19 infection, the dependent, and then the social distancing and vaccination.
Or independent, right? Yeah. Right. So we agree, right? So COVID-19 infection depends on social distancing and vaccination. So we have again 2 independent variables and 1 dependent variables. How about the last one? What if you want to understand the effect of price and availability on sales? So what's going to be your dependent and what's going to be your independent?
Sales is going to be the dependent, and price and availability are going to be the independent.
Yeah. Yeah. So, right. So in this case, again, we have 2 independent variables, right? Price and availability, and then 1 dependent variable, sales. Okay. Right. So far, good. All right. So basically, let me go to this one. So just like the simple linear regression, we are going to assume that y and all of the x's are linearly related, right? Through the parameters beta naught, beta 1, beta 2 to beta q. And there is, of course, an epsilon term, which is, again, the random error that cannot be explained, right? And then we'll look at a sample data. And again, our goal would be to come up with this regression equation. Which means that our goal would be to get this B0, B1, B2, and up to BQ, right? So if we have, let's say, 2 independent variables, our goal would be to get B0, B1, and B2, so that we have a regression equation. And then we can use that equation to predict unknown values of Y based on values of X's, right? Based on values of independent variables. So I'm going to show you again with an example how to do that. And we are going to, let's go to the example called Butler with deliveries. I'm gonna wait for a few seconds in case you're pulling it up to work with me. All right. So as I said, we are going to look at the Butler's problem, the same problem we looked at last time, but I'm just going to keep adding more variables to it, okay? But the base problem is the same. So in this case, as you see in the data, we have data for 300 assignments, right? And for each assignment, we have the data that how many miles does this person need to travel, how many deliveries they need to make, and how much time it takes to complete that assignment. So last class, we looked at data where we only had miles and time for each assignment, but now I have also added one more column which says deliveries, right? So basically, the first assignment, assignment number 1, for example, covers 100 miles, delivers at 4 places, and takes 9.3 more hours. Okay. Second assignment, again, covers 50 miles, max 3 deliveries, and 4.8 hour time. So the manager now, with this data, the manager now wants to understand or predict travel time, based on miles and deliveries. So in our regression, based on that, what's going to be the dependent and what's going to be our independent? So the manager wants to predict the travel time based on miles and deliveries, right?
The dependent variable is time, and the independent variables are deliveries in miles.
Yeah, exactly. Thank you. So our miles and deliveries is going to be independent and time going to be dependent, right? So another question, what do you think would be the relationship between deliveries and time? So do you think they will have an increasing relationship or a decreasing relationship? In other words, if you do the regression, would you find the coefficient to be positive or negative? So if it's positive, that means it's increasing. If it's negative, that means it's decreasing.
Positive.
Positive, right? Because ideally, intuition, you would think that if you have to cover the same miles, but you have to stop at more places to make that many deliveries, that means that it would take more time, right? So if we do the regression, we should get the coefficient to be positive. All right. So now for your sample regression, if there was just one dependent, one independent, we would have gone ahead and do a simple scatter plot and then get the equation, right? But if you remember, scatter plots are 2D, right? It's two-dimensional, right? So which means that you have one X and one Y for your scatter plot. But here I have two X's and one Y, which means that a scatter plot regression equation wouldn't work, right? Because scatter plots are fundamentally 2D. You could still do scatter plots, just to check the relationship, you could still do scatter plots with time and each of the independent variables individually, but you cannot do them together. All right, so because of that, now we need to use more sophisticated tools to do regression. So towards that end, what you need is something called analysis toolpath, right? So if you have already gotten analysis toolpath, then it should show up under your data. So if you click data, it should show up right here, data analysis. If it doesn't, that means you don't have analysis toolpath yet. So let's get it together. I mean, I do have it, but I will still show you how to get it, right? So if you don't have it, you would go to File first. And then you would go to Options down here. And then you would go to File, Options, and then you would go to Add-ins. So once you see add-ins, you're gonna see down here, there's something called Manage Excel Add-ins, and you are gonna press Go. Once you do that, you'll have a few options. I just want Analysis Toolpath for this class, so you just select Analysis Toolpath. You could also go ahead and select Solve or Add-in because later in the semester, we will also use that add-in. But for now, only Analysis Toolpath would be fine too. So you'd select Analysis Toolpath and then press OK. Once you do that, under your data, you should see data analysis. I'm just going to pause here for a few seconds just to see if you have any questions on how to get it, or if you're struggling to get it. Again, if you're not following, that's fine. All right, so if there are no questions, let's then begin. So once you get the data analysis, you're of course going to click on it. And then within this analysis tools, you're gonna scroll down to find regression. So once you get regression, you're just going to hit OK. Because we're going to do a regression, so you're going to just pull up regression and click OK. So once you do that, this pop-up box is going to come. The first thing you need to tell Excel is what is your input Y range, right? So what is Y? Y is your dependent variable, right? So where is dependent variable? What is the range of dependent variables in your Excel workbook, right? So it's time, we know. So we are going to select all of the time. Now you can either do it, so you can either just select time and then drag it down until 300. Or what you could do is you could just select on time and then hit Control, Shift, and down arrow together. Again, so you're gonna just select time and then hit Control, Shift, and down arrow. If you're using Mac, at this point you will be doing Command, Shift, and down arrow instead of Control, Shift, and down arrow. So every time I do Control in Windows, you need to do Command. All right, or you could just drag it down by hand. That's fine too. So your Y input range is D1 to D301. Right? Those are all of your Y data. Next, Excel wants to know what is your X range, right? Where are your X data? So what should I select for my X?
Miles and deliveries.
B1.
So we're gonna start at B1 and I'm gonna just select both of them together, B1, C1. And then you can hit Control, Shift, and down arrow or just manually drag it down to select everything. Okay? And if you're using Mac, you're gonna do Command, Shift, and down. So it's basically going to be B1 to C301, all of that. Now, whenever you're doing regression, you need to make sure that your X's, all of your independent variables, are together at the same place. So Excel, if you, for example, if miles is in B and deliveries is in E column, Excel cannot take those. Okay, so they need to be side by side. So it has to be B and C. So if you have data like that, you have to move it around to make sure that your independent variables are side by side so that they can be selected together. Okay. All right. Now you'll see down here something called labels. So did we select labels or did we not? By labels, I mean, did we select these names, mile, delivery, and time? So which is the
Yes.
one? Yes. So if you did select labels, you have to click this. If you don't click this, then you're gonna get an error from Excel. You could also not select labels and not click labels. That also works. But I strongly suggest that you do select labels because it's easier to read the output that way. Otherwise, you might get lost in reading the output. Okay. And everything else, I'm just not gonna put anything right now. We're gonna talk about confidence levels and things like that in our later classes. And then so next thing I'm gonna put is output range. So for output range, you can put it basically anywhere you want, right? Whatever place you want to put your output, I'm just gonna select it to here. So I just said put in F1. Again, any place that is not occupied, you can put your output. You could also put your output in a different worksheet. So it will come up as a sheet 2. Your whole output will come in that sheet. You can also do it in a new workbook if you want. But really, I think for these small regressions, doing it in the same sheet is probably the most efficient. And then that's basically it. I'm not gonna play with residuals or normal probability in this class, but later on we will work on them. So that's basically it. Once you do that, go ahead and hit OK so that you will get a regression up. And then we'll talk about how to read that. I'm just gonna wait here for a few seconds again in case anyone's following and need a little bit more time.
Yeah, could you give me just 1 second? I'm trying to pull up Zoom on my other screen because it's too hard to follow along on one.
Yeah, I totally agree. Yeah, I'm gonna pause for a few seconds so you can take your time. All right, let's go. So go ahead and hit OK if you haven't done already. And then it'll come up with this summary output. Right? If you're using Mac, your outputs are gonna look a little bit different, and that's fine. And by that I mean the numbers might look a little bit like rounded up or rounded down, but that's fine. In this class, I'm never gonna look for the exact number. I'm only gonna look for numbers that are around the right number. All right, so today we are, in your output, today we're gonna talk about two things. One is the R-squared, and the other are these coefficients. All right. So, do we remember, or anyone can pull up your workbook from the last class where we did our first regression, and that regression was time versus miles. So we remember what was the R-squared for that regression. Can anyone pull up that? Pull that up. R-squared.
R-squared was 0.6641.
Good, thank you. 6641. Now today we did another regression on similar kind of data. What I did is that yes, there are more data sets, but the basic difference is that I added one more variable, right? So now the data is times versus miles and deliveries. And I find that my R-squared is 0.81735 or 73. I can just keep that. So, which model is better? Is regression 1 a better model or 2 is a better model? And why?
Model 2 considers more data and so would be more accurate, right?
Well, I think so. When we talk about accuracy, the way to measure accuracy, and one of the ways to measure accuracy is R-squared. So basically, R-squared tells you how accurately the model will be able to predict the unknown. So it's not, of course, it has more data, but it's not because it has more data. It's mostly because this model, the regression 2 model, has a higher R-squared, right? So the difference between the model 1 and model 2 is that now we have one more independent variable, which is deliveries. So we are trying to explain time with respect to both miles and deliveries. And what we find is that the R-squared significantly improves, right? So there is a significant change in R-squared, almost 20% change in R-squared, not 20, but 17% maybe change in R-squared. So the difference between the R-squared tells us that by including the number of deliveries in your model, you can increase the predictability of the model by 20%. So regression 2 is a better model because it has a higher R-squared. Does it make sense? Okay, cool.
I got a question. Where did you get that 0.6641 again?
That number, so it's basically what we did last class. In last class, we did a regression with time versus miles.
I just used the formula.
We did a regression, we used a scatter plot and the regression equation, and then there was R-squared. We can, yeah. So, we can even do it again, right? So let's do the same regression model with this new data, and let's see what happens. So I'm just going to do it quickly. So I'm going to do a regression where my input y is the time, but my x, I'm only going to choose miles. Okay, and I'm going to put my output somewhere here. Maybe I'm going to put it up in a new worksheet. And then click OK. So now you see there is a new sheet which gives me the output. And in this data, actually, the R square is even low with this 300 data. So this is just 48%, right? 0.48. But if we consider deliveries as well, then the R square improves to 0.81. That means your regression 2 is a better model for this data. So again, we also see that just having more data doesn't mean that you're going to have a better model, right? So in this case, we do have more data, but if we only include miles in our model, our R square is 0.48. But if we increase both miles and deliveries in our model, then our R square is 0.81. So this is definitely a better. Any questions so far? Did I confuse you, lose you? Are you with me?
What is R squared, like in English? Like,
Yes, so R square in English, you can say, I'm going to write it down for you. How much of the variability of, in this case, time, can be explained by a regression equation. Okay, or by a regression model, you could say. So if we can explain more variability of your time or of your dependent variable, that means that it's a better model because it will be able to predict your dependent variable better for unknown values. So it basically tells you how much of the variability can be explained by this regression model. We want to be able to explain as much as possible because that will minimize the random error term that we talk about. So it's basically the same thing. It's basically also minimizing the random error term that we have in our regression. Okay. Great question. Any more questions? So actually, that's a good.
So that would mean that only like what 18 or 19% of the variability could be explained by like traffic or things like that.
Yes, based on this data, yes, that's what it means.
Okay.
The unknowns that we don't know, and we are not capturing, everything that we are not capturing, right? That explains the rest of the 18-19% variability of it. All right, great questions. So in your question sets or like assignments, sometimes you will see I'm asking this question, that how much of the variability of the dependent variable can be explained by a regression model. So just to be more holistic, right? And the answer I'm looking for is an R square. So if I ask this question for regression 2, you're going to tell me 81%, or 81.7%. So that's the answer I'm looking for. We will do this question answering multiple times, so you'll get used to it on the language, I'm sure. All right. Any more questions on R square? Okay. So one thing, if you notice that when we did regression with a scatter plot, then we already had the regression equation written down, right? But right now we don't have it. So we have to write down our own regression equation, right? And the way we will write down the regression equations is using these coefficients. Okay, so basically these coefficients are your B0, B1, and B2. So this is your B0, this is your B1, x1, and this is your B2, x2. And the way you write your regression equation is basically like this, right? So y equals to, because we have two independent variable, b1 multiplied by x1 plus b2 multiplied by x2. So can anyone help me to write the regression equation with respect to this particular regression? So how are we going to start? What is our y? Or the dependent variable? What is the dependent variable?
Time.
Time. Let's go. So Josh?
Yeah.
Okay. So time equals to, then what?
The
So you're gonna
intercept or 0.12734
0.12734, then
plus
plus
0.06718 times x1, or do we have x1?
yes. So your x1 is miles, right? So
Oh, right.
b1 is corresponding x1. So that's gonna be miles. Then
Plus 0.69 times deliveries.
right. Very good. Thank you. Okay. So if you now if you don't select your labels in your regression, you're not gonna get these names, miles and deliveries. So that's why I don't think it's a good idea to not include labels. So any questions on how to write regression equation? So every time I ask you to do your regression, I will ask you to give me the regression equation. So once you get the output, you have to write down the regression equation. And this is our model, or this is the equation, right? Because now if we have an unknown miles and deliveries, we can predict the time to complete that assignment. Right? So for example, let's do a prediction. I can ask what is the predicted time to complete an assignment that covers 100 miles and 6 deliveries. Can anyone give me the number?
So B0 is the intercept.
Yes. B0 is the intercept. That's right. So your B0, or you can say, basically, this is your B0, right? Let's see. This is your X1. And then here you have B1, and this is your X2, and here you have B2. So basically, these are your B's. All right, so can you guys do the calculation and tell me what is the predicted time to complete an assignment that covers 100 miles and 6 telegrams?
10.9855.
That's what I got too.
Okay, great. So I think you guys got it. Just to make sure, just 2 miles plus and then I'm gonna put 100 for miles and then 6 for just 10.985. Great. All right, so we understand how to, so far what we covered, we understand how to do multiple regression using regression tool. We know how to read the output and write down the regression equation. And then we also know how to use the regression equation to predict an unknown value of 1. Okay. All right, so just for completion, I also want to talk about the interpretation of this coefficient, right? So remember we talked about the interpretation of the coefficient that associated with the independent variable before, right? For example, so I'm gonna say interpretation of, in this case, interpretation of the number 0.0671. So I'm gonna just call it interpretation of P1. And the B1 is a number of 0.067. So if there was no deliveries, when we did only simple linear regression, we said that this number basically means that if you include 1 more mile in your assignment, then on average, your travel time is going to increase by 0.06 hours, right? If there was no deliveries. So this is what it looked like, right? If basically if miles is increased by 1 unit on average, time will increase by 0.0672 hours. Right, that was the interpretation. Now, will the same interpretation work here? The answer is no, because now we not only have miles, we also have deliveries in the model. So we have to talk about what happens to deliveries when you're increasing miles. Are you also increasing deliveries, or are you keeping deliveries the same? So whenever you have multiple independent variables, then you have to talk about what happens to all of them. So what do you think is the interpretation of 0.067? Is it that you're increasing both miles and deliveries? Or is it that you're increasing only miles and delivery stays the same? So you can look at the equation and that should give you some hint. Sorry, I did not get that.
I was saying, can you repeat what you just said, please?
Yes. So what I said is that it's not enough. This interpretation is not complete, what I wrote, right? Because it doesn't say anything about what happens to deliveries. Right now, our model has both miles and deliveries. And the interpretation only talks about miles. So in this interpretation, basically it's incomplete in the sense that we don't know what happens to deliveries when miles is increased. So my question to you is, can you think about completing this in the sense that what do you think would be the interpretation? Should the deliveries also increase, or should the deliveries stay the same when you are interpreting the number 0.067?
That should increase too, right?
Sorry, I did not get that.
That should increase too.
I did not get that.
Deliveries stay the same.
Yes, exactly. So the delivery stays the same here. Because if you increase deliveries too, then your time would increase 0.06 plus 0.69. So 0.067 is the increase in time if miles increases by 1 unit while delivery stays the same. So you do have to mention that in your interpretation. So you're going to say if miles is increased by 1 unit while deliveries stay the same. Does that make sense? So for example, what would be the interpretation of 0.689 then? Can anyone follow through the same logic and let me know?
If deliveries increases by 1 unit while miles stays the same, on average, the time will increase by 0.68999.
Great. We agree? So this is how we're going to write interpretation in multiple linear regression. We have to talk about all independent variables, right? So one's going to increase and other's going to stay the same. So if I'm going to just do copy paste. So here is going to be deliveries, and here's going to be miles. And an average time will increase by 0.689. Okay. All right. Good. I think that's all for multiple regression with numerical independent variables. I do have a practice problem, and I don't think I will have time to go over this in the class. But what I will do is that on our classwork day, which is next Tuesday, I'm gonna start with an example to warm you up, and then we'll do a class. Okay? But you're welcome to try that on your own at home just to practice a little bit before our classwork day. So the example is here, the Dixie Showtime, and the question will be in the Excel workbook as well. So we're gonna take a 5-minute break, and when we come back, we're gonna talk about categorical independent variables. So we'll be back at 1:56.
So remind me again, where are we planning on meeting on Tuesday?
All right. So so far we looked at independent variables that are numbers, right? So everything was miles, deliveries, there were some numbers. And as I said, we are also going to today talk about what if they are not numbers, but a category, right? And those are called categorical independent variables. So for example, let's say you're trying to figure out how much people shopping behavior, right? So that might depend on what gender the shopper is, and that will not be a number, right? That will be a category. It will be either male or female or others. Also, it might depend on the method of payment, right? So maybe the people who are paying cash, they're buying more expensive stuff. So if you want to understand that behavior, whether the method of payment affects the purchasing behavior or not, you will look at data where you have method of payments, right? So it's not going to be 1, 2, 3, 4, 5. It's going to be, let's say, cash, credit, or check, right? So again, these are categories, these are words. So we are going to learn how to use and interpret this categorical independent variables interpretation. So if you have a data where you have words instead of numbers, you cannot simply give it to Excel and ask them to do a regression. So Excel is not going to do a regression. It's going to show you an error, right? So we will see how to first create numerical independent variables based on the categorical independent variables, and then use them to do a regression. All right. So for this part, we are going to look at the data set called Butler Highway. So this is the data. I'm just going to give you a few minutes to pull up the data. Real quickly.
Are these worksheets on Canvas?
Yes,
Okay, perfect.
it's called Butler Highway.
Excuse me. Are we supposed to be turning these in, or are they just for a practice?
Just for practice, yeah.
Thank you.
All right, so if you look at the data, again, it's the same structure, right? It's the same context. We are looking at data from Butler Trucking Company, and the manager is trying to predict time based on few factors. So last example, we saw we have miles and deliveries. So number of miles they have to travel to complete the assignment and number of deliveries that they make during the assignment, right? But now I have added also one more column, which is called highway question mark, right? So what this column tells you is basically whether or not this during this assignment, whether or not the person needs to go through a busy period highway traffic. Okay? So there is a highway traffic during rush hour, and basically the manager is trying to understand whether that highway traffic impacts the travel time in any way. Right? So you will see the data is basically yes, no. No means no. The assignment, during the assignment, the person will not go through that highway traffic during busy periods. And yes means yes, that assignment will go through on highway busy period traffic. Right? So what do you think this highway, how do you think it's gonna impact time, positively or negatively? Just so that we are understanding the data.
I would
No
say
is negative and positive, or yes is positive.
Right. So if you are going through that highway busy period, that means you're gonna take more time, right? Just because there is a traffic. So yes, it's going to be a positive or increasing effect. Right. So as I said, Excel, if you just give Excel this data and tell, hey, run a regression where my time is dependent and miles, deliveries, and highway are independent, Excel would show that there is an error. Why? Because Excel cannot read this yes, no data. So what we have to do is we have to create something called a dummy. So whenever we have a categorical independent variable, we have to express it numerically through a dummy. So the first thing we're going to do is create another column where we're going to write down our dummies. Okay. So to do that, we are going to select the D column or the column variable highways, the full column, and then go ahead and do a right click if you're using Windows and a control plus right click if you're using a Mac. Okay, so every time I use right click on Windows on Mac, you're gonna use control and right click together. If you do that, you'll see an option to insert. So you want to insert a column, a full column, where basically you will code the highway dummies. All right, and then I'm going to label these as highway dummy. Okay, question. Why do you think I created the dummy on the left of highway and not on the right of highway?
So when you like get all the information, you don't have to you can do it all at once. Like when you highlight it, miles delivered and highway done.
Right, so we have to highlight, when we finally do regression, we have to highlight all of them together. So we have to make sure that the independent variables are sticking together, right? If I did the highway dummy in here, I couldn't select miles, deliveries, and highway together in regression. So it's important that your independent variables in regression are sticking together. Okay. All right. So how do we create these dummies, right? The way we are going to create dummies, and this is true for all dummies, is that we're going to say, we're going to code in a numerical value, and the numerical value is going to be either 1, so it's going to be a binary value. What does binary mean? So it's going to be either 1 or 0. Now, when it's 1 and when it's 0 depends on the data, right? So we're going to say that if my highway variable is no, then give me 0. And if my highway variable is yes, then give me 1. Okay, so I want to write down a code which basically tells me that if the assignment does go through highway, then give me 1 for the dummy, the number 1, right? If it does not go through highway, then give me the number 0. So every time we create dummies, we're going to create zeros and ones. It's just going to depend when you create zeros and ones, how are you going to create it? That's going to depend on the problem or your categories of variables. Okay. So any suggestion on how to, or what function can I use to write down my dummies? So I want to write down that if highway is yes, if the highway variable is yes, then it's 1, otherwise it's 0.
What about the if function?
Exactly, very good. So we're just gonna use if function, okay? Right. So, awesome. You guys already know what I need to teach. So if, and then you're gonna test if your highway variable equals to yes, then give me 1, otherwise give me 0. Okay? So Excel helps you with any function you want to write down. So first you have to write down the test. The test is if my highway variable is yes. If yes, then give me 1, otherwise give me 0. Now you could also write it in a way that you could say if E2 equals to no, then comma 0, comma 1, it would mean the same thing. You could also code in yes, no differently. But again, you have to remember and you have to be consistent with how you are coding it in and how you're reading your regression equation. So let's first understand this coding and the equivalent regression equation, and then maybe I'll tell you what if you code it in a different way. So is this formula clear? Does it make sense what I'm trying to do?
Yes, ma'am.
Okay, good, thank you. So once I do that, just hit enter. So this gives me 0, which is good, right? So I want 0 because it's no. The corresponding highway is no. So once I've written down one formula, you could either drag it down to fill it up, or you could hover around and wait until you get this plus sign. Once you get the plus sign, you could just double click. So if you did everything correctly, then you would say that your yes are 1. So your highway dummy would be 0 for all the no's, and it would be 1 for all the yeses. Okay, any questions so far? So now go ahead and do a regression, right? So now we are gonna go ahead and do a regression where we would use time as dependent as before. And then we're gonna use miles, deliveries, and highway dummy as independent. So we're not gonna use highway, we're just gonna use highway dummy. Okay. So let's go to data analysis, and then regression. And then let's delete everything because Excel remembers what you put in. So it's always gonna start with something that you have used in the past. But let's delete everything and then go ahead and do your Y range. So now your Y would be in your F column because it's time, but it's located in F column. And then Control Shift Enter. Or you could also manually drag it down. And then for your X, you're going to use miles, deliveries, and highway. And then Control Shift Enter or Command Shift Enter or manually drag it. Did I select labels? So should I check on labels or not? Yes, right? We should check on labels. And then I'm gonna use my output range as right here. And then just keep everything free and then hit OK. Okay, I'm gonna again pause for a second to see if you have any questions. All right, so once you do that, hit OK. And then let's look at my summary output. All right, so first thing, we are gonna look at R squared. All right, so previously my R squared was what? 0. For regression 2, the regression that we had. Basically, in that regression, we had time versus, just write down here, time versus miles and deliveries. Okay. For that regression, our R square was was 0.817. So now we included one more variable, and right now my regression is basically I'm predicting time with respect to miles, deliveries, and highway. Highway deliveries. And my R square is 0.8838. So which regression, which model is better?
The second one.
Right, the second one, right? Because we have a higher R square, and basically the highway dummy explains 7% more of the variability of Y, right? So it can explain 7% more. It's just the difference between the R squares. All right. So next, let's write down my regression equation.
Where are we getting the 0.817?
Oh, that's just something that I remember, right? So it's something that we got last time.
Oh, okay. So that's like for the single variable.
That's for the two variables when we had miles and distance.
When we just had miles.
So when we just had miles, that was 0.48. That was even lower. So we first did just miles with the same data, right? Then it was 0.48 in the sheet. And then we did miles and deliveries. Then it became 0.81. And now we did miles, deliveries, and highway. And now it's 0.88.
Okay.
Okay. Good question. All right. So can anyone help me write down the regression equation?
Which one?
This one, the current one. So based on these coefficients, right? No one wants to speak up?
Which one is
So-
the dependent?
So what is my dependent variable? What am I trying to predict? Time, right? So dependent is always time. Because time is what we are trying to predict or we are trying to estimate, right? So we are trying to understand how time depends on miles, delivery, and highway done. So we are going to start with time equals to
Negative 0.33023 plus 0.06722 times deliveries.
No. What is the associated?
Oh, miles.
Okay.
Plus 0. What is it?
67352.
Yeah, that times deliveries. And I think the next one is plus 0.998 times highway dummy.
Very good. All right. Thank you so much. All right. So this is my regression equation. We all agree, right? Any questions? I guess not. So let's do a prediction. So let's see. Predict estimated time for assignment that covers 180 miles, does 8 deliveries, and does not go through a highway during rush hour. So can you give me the predicted time?
17.157.
Okay, let me do it. 17, fine. Anyone else good? So my equation is going to be intercept plus this multiplied by miles plus this multiplied by deliveries plus this multiplied by how many? Okay. So my miles are 180. Deliveries 8. And what should I put for highway dummy?
0.
We should put 0, right? Do we understand why we are putting 0? We're putting 0 because this assignment does not go through a highway. And how we coded it is that we said if it does not go through a highway, your dummy is 0. So the way you would code it is the exactly way you would predict it, right? They just have to be consistent. Okay. All right, so I'm gonna put 0. So that gives me 17.157. All right. Any questions? Pretty straightforward, right? So before we leave, I do want to mention one thing. No questions about the prediction, right? Okay. And then also similarly, you could, let's say, what would be the interpretation of 0.998 number? The coefficient for highway dummy. So the interpretation of that would be everything else being equal, all else equal, or you can say everything else being equal, if the assignment covers highway during the busy period, then on average it will take 0.998 hours more. Okay. So what I'm trying to stress here is that whenever you are interpreting coefficient in multiple linear regression, you have to say everything else being equal, right? So nothing changes except the variable that you're the coefficient that you're explaining, right? So nothing changes except the variable associated with the coefficient that you're explaining. So in this case, you're explaining the coefficient of highway dummy. So you have to say everything else being equal, meaning that miles and delivery stays the same, right? In that case, if your assignment covers a busy period highway, then on average, you're gonna take 0.99 hours more to finish the assignment. Okay, makes sense? All right, so the last thing I want to talk about is how do we know or how many dummies to create? So in this case, we just created one dummy. That's a highway dummy. There would be cases where you need to create more than one dummies. So how would you know how many dummies to create? Now, the way you would know it, was there a question?
Never
So the
mind.
way- Sorry, is there a question? So the way to determine how many dummies to create is going to be this. So the number of dummies would be equals to number of levels in a categorical variable. And I'm going to explain what I mean by that. Minus 1. So what does the level mean? Level means that how many types of categorical variables you have in your data. So for example, in the highway categorical variable, you have the data could be yes, either yes or no, right? So it is not anything else, it's just yes or no. That means that your level in this case is 2. And that's why we created just one dummy, because in this case, your level is 2. So the number of dummies to create would be 2 minus 1, which would be 1. Okay? So now let's think about the case where, like I said, we are using a method of payment as an independent variable. And method of payment could be cash, credit, or check. So how many dummies would I need to explain this categorical variable? How many dummies?
2.
2, right? Because we have how many levels? We have 3 levels of this categorical variable. Cash, credit, or check. So the dummies that we need would be 3 minus 1 equals 2. Right? Okay. So how to create multiple dummies? I think we're going to talk about it later. I do have an example here. But I'm not gonna go over that today, of course, we don't have the time. But later we will see how to create multiple categorical variables. Okay, multiple dummies, sorry. Multiple dummies based on the levels of the categorical. But it's basically very similar to what we did today. It's just how you're gonna code in the zeros and ones, it's gonna matter. All right, so that's all for today. And I'll see you in person next Tuesday. So please wait for me to send you an announcement. So I will send an announcement before or by Monday to where to meet on Tuesday. Okay. Thank you. And if you have any questions, feel free to stay back, and then we can go over any questions you have. Okay.
Yeah, I had a quick question.
Let me just stop recording and then